Hello to all. Hope you are all good and doing fine. Today it is gonna be my second video, and in this video we are going to discuss the types of physical quantities. So here we start. As per the textbook, the physical quantities are of two types. The first one is fundamental physical quantity, and the second one is derived physical quantity. So first of all, I'm going to discuss about fundamental physical quantity. So here are the some statements written over this page. So let me discuss each one by one. These are the quantities which are the basically the base units and defined by the GCWM. It is a general conference on weights and measure, and these physical quantities are defined in SI system of units. And if I scroll it down, then you can see these are 7 in numbers, and these are the units, and these are their corresponding symbols of unit, right? And this table is not so difficult to memorize because these are just only 7 in numbers, and I hope you can memorize it very easily, right? Here I'm not going to discuss the standard definition of these 7 fundamental quantities, because here at this initial stage of this video lecture series, it's gonna be very confusing for all of the students, right? If required, then I will discuss these all things in some other video. Okay, so do memorize this table, and I think it is not so very difficult, right? Okay, now these fundamental quantities are used to construct the all other physical quantities, and here as we move ahead in this video we will see how it can be done in terms of derived physical quantity. Okay, now I come to the next. There's no independent relation exists between any two fundamental physical quantities. If any relation exists, then it should need to involve some other physical quantity, right? So let me discuss these two statements very clearly here. Now suppose let me do write an equation s equal to t, and let's suppose this s is length and this t is the time, right? And if I rearrange this equation, then I can write it down as s upon t equal to 1, right? Now you can see, this is a number, right? This is a number, and that is equal to 1. What does it mean? It means that these two quantities s and t are identical, and it is the only possible case when you get this much quantity equal to 1, right? But here we have already defined this as is the length, and this is the time. So how we can say this the whole quantity comes out to be equal to 1? And it is like the same situation if I say tomato is equal to apple, right? And of course it is not equal, right? Because after all, you are comparing the two different quantities. This is a vegetable, and this is a fruit. So how you can compare this to this, right? So it is not acceptable, right? And now what I'm going to do next, I'm taking the same equation again, s equal to t, but here is a unknown entity, and I don't know what is this, so let me put it as x. And again, if I rearrange this, then I can say x equal to s upon t, right? Now this time you don't know what is this quantity is, right? And some of you may raise your hands and can say, well, it is equal to the speed, right? Speed equal to distance upon time. And you know what is the unit of this? This is meter per second, right? So what is the difference between this equation and this equation? This equation is an independent equation which does not exist practically, right? And this is dependent equation. Basically, this is the relation between the two fundamental quantities that involve some other physical quantity. And you know what is this quantity? This is speed, right? And I hope it is clear to all of you what is the meaning of these two statements, right? Now let me do scroll it up. And these seven physical quantities are sufficient to construct the whole world of units. Let me do underline this group of words. And you just keep this thing in your mind, because I will be using this group of words again and again in my subsequent lecture also, when we are going to discuss about dimensions, right? Okay, now this statement gives rise to the concept of derived physical quantities. So all those physical quantities which are expressed in terms of fundamental physical quantities are called derived physical quantities. For example, as we have seen here, this speed is derived physical quantities because it is expressed in terms of length and time, which are basically the fundamental units, right? And here there can be a lot of examples of that physical quantity. So again, let me do write it here. V, let me change the color first. So this V equal to, again, this is S by T. And we know that acceleration is V by T. So now from here I can write down the unit of this speed. This is a meter per second. And when you substitute the value of a unit of this speed, this is a meter per second, and this second is in the denominator, and it will give you meter per second square. And here now suppose you want to find out the force acting on a body, and you know this is the mass into acceleration. This mass is a fundamental physical quantity, so it is measured in terms of kg, and here this is the acceleration, which is meter per second square, and we know the whole quantity is known as Newton. So this is Newton. And continuing in this manner, let me take the next one is power. Power is force. Power is force into distance divided by time. And you know what is this quantity? This is work. So actually the power is defined as work divided by time, and from here you can again construct the unit of power. So let me do write the unit of force here, which is kilogram meter per second square, and this is the distance, so I can raise this power to 2. And here it is in the denominator, this is second, and that will give you kilogram meter square second minus 3. So in this way we can construct the whole world of units. And of course the number of derived physical quantity is very large and it is not so easy to remember or memorize. But you don't need to worry about it because in this lecture series, I will explain each and everything in detail. So stay tuned with me. And now we move ahead. And finally, I want to give the answer of these two important questions. The first one is what is the necessity of selecting subunits as fundamental quantities? Well, the answer of this question is now suppose if we consider a separate unit for each and every physical quantity exists in science, then of course the number of units will be very large, and it will become very difficult to memorize if we assign a separate unit, right? So in this way we have to select some basic units so that the other physical quantity can be constructed in terms of fundamental quantities, right? And the next one is, why are only these seven physical quantities selected as fundamental units, not others like velocity, force, acceleration? Why we cannot connect these select why we cannot select these quantities as fundamental quantities, right? Okay, so one of the reason of selecting these quantities as fundamental units, because these are called quantities which are listed here in this table are easy to measure, right? For example, if I say which one is easy to measure, length or speed, so I think length is comparatively easy to find out as compared to the speed, right? Now let me give you a explanation about it. Now suppose a person is moving from A to B, and he does not know the distance between the point, but he can measure the time, right, in traveling from A to B. I don't know what is the distance between A and B, but he can measure the time very easily by using his watch. Now suppose the time taken is 10 seconds, right? Now the next question is how he can find out the speed of his movement from A to B. Well, what we can do in this case, he can measure this distance A to B by using a meter scale if this distance is not so very large, right? Now suppose if he measure this distance AB and it comes out to be like suppose 100 meter, right? So again he can find out the speed by using the same formula as we did the last time, x upon t, and this is 100 meter divided by 20 second, and it comes out to be 5 meter per second, right? So which one is easy to measure? Of course, for measuring the speed he has to depend on the distance and time. So in this way we can say the measuring distance is comparatively easy as compared to the speed, because the speed depend on x and t, and of course there's a no speedometer attached with him so that he can measure the speed directly by using the instrument, right? So in this way we can say these all things which are listed here in this table are comparatively easy to measure, right, in this table, right? And if you want to select any other physical quantities as fundamental quantities, then you can definitely do it. But remember one thing, you just keep your opinion with yourself only, because the set of the fundamental units is already defined by the scientist community, and no one will take care of your opinion unless or until if you are going to be a famous scientist in your future, right? But the one thing is very good for you. If you select some other quantities as fundamental quantities, then you can construct some questions as I did here, If force, power, and momentum are selected as fundamental quantities, then express mass, length, and time in terms of these assigned fundamental quantities. So, first, understand how we can approach this particular question. First, you need to write the formula of force, power, and momentum. And of course, force equal to mass into acceleration. So I can write in terms of mass into acceleration. Let me assign some notation for mass. I have taken m, and acceleration is this a. If I split it further, acceleration, then it is L upon t square. Right, now suppose this is the equation number 1, and for momentum I write mass into velocity, and this is mass L upon t. This is the equation number 2, and the third one is power. Right, for power, that is work upon time, and this work is what? Force into distance and divided by time, and this is force is mass length upon t square, and this is L, and this is T. So it gives ml square t cube. This is the equation number 3, right? Now I need to find out mlt in terms of f, p, and p. Basically, this is the power, so I make differentiation p naught. I assign the power as p naught, right? So can we solve this? How? Yes, if I divide equation 1 by equation 2, then it will give us f upon p equal to mlt square t upon ml, right? Ml will cancel out, f upon p, that's will be 1 upon t, and t comes out to be p upon f, right? So this is the equation which gives us the expression of t in terms of p and f, right? And now from here, and the next thing which we can see from equation 1 and 2, if you multiply equation number 1 and 2, then it gives us f into p equal to ml upon t square, and this is ml divided by t, right? So it gives us m square l square t cube. Now suppose this is equation number 4. Now if you divide equation number 4 by 3, then it gives us equation number 4 divided by equation number 3. It gives us m square l square by t cube. That will give us t square ml square, right? So this term is cancel out, l square is cancel out, and 1 power of m is cancel out. So we are left with m, and the right hand side quantity is f p upon p naught, right? So this is the expression of mass, right? And the remaining thing is length, right? So I can directly measure the expression of length from equation number 2. Length equal to pt divided by m. Now substitute the expression of t. This is p upon f, and for mass m, it is f p on p naught, right? So from here p is cancel out, we are left with p naught divided by f square. So this is the expression of L in terms of the assigned fundamental quantities, right? So we have find out all MLT in terms of assigned fundamental quantities, right? So in this way, we can find out the fundamental quantity in terms of assigned fundamental quantities, right? It might be seems very tricky to all of you, but if you practice in this way such types of problem, then you will definitely see it's gonna be very easy to solve out, right? So that's all for this video. And if you have any doubt or question in your mind, then you can do comment in the comment box. I will surely reply your comments. So it's enough for the day. See you soon. Goodbye.